Children, I hope you have gone through my previous video, and today we will continue further. Today in the chapter Chemical Bonding and Molecular Structure, we will study about coordinate bond, which is also called dative bond. Now, coordinate bond is a special type of covalent bond in which both the electrons of the shared pair are contributed by only one of the two combining atoms. The atom which constitutes or which contributes the electron pair is called the donor, while the atom which is receiving it is called acceptor. Coordinate bond after formation is indistinguishable from covalent bond. Okay, they are similar. Sharing is being done by both the atoms equally, but the contribution is being done only by one atom instead of equal contribution by both the atoms. It's just like, if you have a chocolate and you are sharing it with your friend, but there can be another, like both of you have a chocolate and you share the two chocolates between the two of you, but there can be another case in which one person has two chocolates, other has none, and still you are sharing it equally, so each one of you gets one. Okay, so this type of an example of coordinate bond is formation of ammonium ion. Now in ammonium ion, NH3 plus H plus gives you NH4 plus ammonium ion. Now in this, nitrogen has the lone pair of electron and hydrogen does not have any electrons. So this lone pair, nitrogen forms a coordinate bond with hydrogen. Alright. Similarly, in case of ozone molecule, see the ozone has 3 oxygen atoms. So O2 plus O forms the ozone. Now in O2, oxygen has 2 lone pair each. Ozone has 6 electrons. It is short, the oxygen has 6 electrons here, and it is short of 2 electrons. So this lone pair of O2 will be shared with the third electron. Now see, wherever the coordinate bond is formed, it is shown by an arrow to distinguish it from the covalent bond, and the arrow head will always point towards the acceptor atom. Similarly, in formation of nitric acid, nitrogen donates lone pair of electron to oxygen. So this coordinate bond, rest all are covalent bonds, but this is a coordinate bond. The same thing you can see in case of hydronium ion, H3O plus. Now in this, oxygen is the donor atom. It forms a coordinate bond with hydrogen, which is shown by this arrow. Okay. The next example is oxyacids of chlorine. Like first is chlorous acid, HClO2. So in this case, chlorine is donating the lone pair to oxygen. Chloric acid, HClO3. Again, chlorine is donating the lone pair to 2 of the oxygen atoms. So 2 coordinate bonds are formed in this. And perchloric acid, 3 coordinate bonds are formed. All the 3 atoms are electrons for coordinate bond formation are being 3 pair of electrons are being donated by chlorine. So see, one here, and the other here. So this is in case of perchloric acid. So this is coordinate bond. Next type of bonding, that is hydrogen bonding. The attractive force which binds hydrogen atoms of one molecule with electronegative atoms of other molecule of same or different substance is known as hydrogen bond, and hydrogen bond is represented by 3 dotted lines. Okay. A condition for formation of hydrogen bonds: high electronegativity of atoms should be linked to the atoms which are linked to hydrogen, they should have high electronegativity, like they can be oxygen, fluorine, nitrogen. Second condition is the electronegative atom should have small size. Electronegativity of chlorine is same as that of fluorine, but chlorine does not form hydrogen bond as it is bigger in size, but fluorine forms the hydrogen bond. Okay, now next we come to strength of hydrogen bond. Strength of hydrogen bond, it ranges from 10 to 40 kilojoules per mole, while that of a normal covalent bond is 400 kilojoules per mole. So it is a weak bond, not very strong bond, but still a bond nonetheless. See here, this is how you will show the bond by the dotted lines. This is hydrogen, the hydrogen bond between hydrogen and fluorine is stronger than hydrogen bond between hydrogen and oxygen, which is stronger than bond between hydrogen and hydrogen. Now hydrogen bond, it is of two types, intermolecular and intramolecular. First let us study about intermolecular hydrogen bond. This type of bond is formed between two different molecules of same and different substances. It results in association of molecules and increases the boiling point of compound and its solubility in water. In first example, you can say hydrogen fluoride, HF. So this is one molecule of hydrogen fluoride. This is another. Here you are seeing three molecules of hydrogen fluoride. Alright, and all the three, they are linked to each other by this dotted line, that is the hydrogen bond. Another example is water molecule. See, in water you know is H2O. So H2O, this is water molecule, which is shown by, linkage is shown by dense line, okay, straight line. But the between two water molecule, there is a linkage between O and H, which is shown by a dotted line. So that is the hydrogen bond. See here also, this is one water molecule, this is the other water molecule, and in between them this dotted line signifies the hydrogen bond. Second type of hydrogen bond, it is called as intramolecular hydrogen bond. It is formed between hydrogen atom and highly electronegative atom, fluorine, oxygen or nitrogen, which is present in the same molecule. Now here there were two different molecules of water, and between them there was hydrogen bonding, but intramolecular means within the same, inside the same molecule. So it results in cyclization of molecules. Molecule becomes cyclic. Ring is formed. So this type of bonding, it decreases the boiling point and solubility of compounds. Examples of intermolecular hydrogen bond is orthonitrophenol. So phenol is C6H5OH. If NO2 group is attached, it becomes nitrophenol. Alright. Ortho means attachment is at first and second carbon. Okay. So OH and NO2, but the O of NO2 and H of OH, they also link to each other through this hydrogen bond, which is shown by a dotted line. So it forms another ring-like structure. Alright. Similarly, orthohydroxybenzoic acid. So here what C6, the benzene ring, it on first carbon it had COOH, on the second carbon it has OH group. Now the hydrogen of OH and oxygen of COOH, they form a hydrogen bond in between. So that becomes intramolecular hydrogen bond. Now next we come to what are the consequences of hydrogen bonding. The first consequence is dissociation. When hydrogen fluoride is dissolved in water, it dissociates to give difluoride ion in place of fluoride ion. It is due to hydrogen bonding. See here, on dissociating, it is giving you H plus HF2 minus instead of F minus. So this is one impact of hydrogen bonding. Second is association. Now in association, due to, see this is, due to intermolecular hydrogen bonding, two or more molecules of a compound exist as associated molecules. For example, carboxylic acid. It exists as dimers in vapor state. So what happens? This is carboxylic acid, RCOOH. This is another molecule of carboxylic acid, RCOOH. Now the O of one and H of another forms hydrogen bond. Two hydrogen bonds are being formed over here. And now it is existing as a dimer. Already dimeric form it is present in. Next consequence is high melting and boiling point. The compounds containing hydrogen bonds, they have high melting and boiling point. Ammonia, water, hydrogen fluoride have high melting and boiling point in comparison to hydrides of other elements in their group. Water exists in liquid state due to hydrogen bonding in water, but H2S exists as gas due to absence of hydrogen bonding. Next is solubility and volatility. Now organic compounds like alcohols, carboxylic acids, they are soluble in water due to formation of hydrogen bonds with water. Paranitrophenol is more soluble in water than orthonitrophenol because paranitrophenol can form intermolecular hydrogen bond and orthonitrophenol forms intramolecular hydrogen bond. Now due to same reason, paranitrophenol is less volatile than orthonitrophenol. See, para mein what is para condition? Para in condition, the OH is at first carbon and NO2 will be at the fourth carbon. So they are far away from each other. They will not form a hydrogen bond. But in ortho condition, OH is at first carbon of the benzene ring and NO2 is on the second carbon. So they are close to one another. So the H of OH and O of NO2, they form a hydrogen bond. So intramolecular hydrogen bonding takes place in ortho, whereas does not take place in para condition. Alright. Now next is viscosity. Intermolecular hydrogen bonding increases the viscosity of the compound. For example, glycerol is more viscous due to presence of 3 OH groups, which can form a number of hydrogen bonds per molecule. Now next we come to because of hydrogen bonding, water has unique properties. So let us study about the unique property of water. First is that ice is lighter than water. This is because of the tetrahedral arrangement of water molecules in solid state. See, this is the tetrahedral arrangement. They look like a tetrahedron. So the ice structure extends in 3 dimensions and there are vacant spaces in crystal structure. This gives rise to open cage-like structure having large volume for the given mass of water and density becomes less. Second is water has maximum density at 4 degrees Celsius. When ice melts on increasing the temperature, the open cage starts collapsing due to partial breakdown of hydrogen bonds. This allows water molecules to come closer and fill the vacant spaces, which results in contraction of volume and density starts increasing and becomes maximum at 4 degrees Celsius. On further rise in temperature, kinetic energy of molecule increases and they begin to separate. So this causes expansion, which is more than contraction. Therefore, above 4 degrees Celsius, density of water again starts decreasing. Okay, so the maximum density of water is at 4 degrees Celsius. This completes your chapter, chemical bonding and molecular structure. Revise it properly, and in the next video we will start with a new chapter.